Guys, recording is started. Please quiet down. So today, what we're doing, the big parts, we're going to plot equivalent ratios and equivalent ratios on a coordinate plane. We're going to read equivalent ratios from graphs. We'll do a little bit of that, but that's about all we're doing today. The next two parts are what we're going to be doing in our next lesson. Your homework tonight, one Matthew workspace, should be relatively simple. This should put you at 7 out of 20 if you're looking at just Module 2, or a grand total, I believe we're at 37 now out of the 123. Yes? I think this is 7. 5, 6, you're right, this would be 8. Okay, so it's 8 out of 20. That's the name of it, just to be safe. Okay, go ahead and open up your modules to page 223. Your math books. So again, here's your 2 goals. Here's the first thing we're going to do. A tree grows at a constant rate of 3 feet per year. So we need to write a ratio to represent the amount of growth in feet to the number of months, and create a double number line that will describe the growth of the tree every 12 months over a 48-month period. So it should be relatively simple. I'll give you guys about 3 minutes to knock these 2 out. Guys, quiet down. So our first one, we need to write the ratio. We haven't done a whole lot of this, but they changed the units on us. So it went from year to month. So the only thing that really changes on this is it's now 3 feet and 12 months, which I could simplify dividing those by 3 to give me 1 foot every 4 months. They didn't ask you to do that part, so you didn't have to. So you should at least have that, though. You could also have written it as a ratio format. So if you wrote it this way, that is also acceptable. So either one of those ways would work. Doing my double number line should have been super easy because they gave us most of the information, right? Yeah. So what number is going to go above the 12? 3. What number is going to go above 24? What's going to go above 36? And above 48? Questions on either of those? Okay, here's where I really need you guys to listen and pay attention. There's a lot going to go on here. So, our first part of this, we're actually going to have you cut out a whole bunch of rectangles. And you're going to do some things with them. So, I need everybody's attention up here, please. Let me go through the instructions first, and then we will go, I'll let you guys work. I see everybody's eyes up here. Emily, I see all eyes up here. Thank you. Emery, thank you. Okay, cut out and analyze rectangles located on page 239. We'll go to that in a minute. Don't go there yet. After you've done that, you're going to see you have 2 copies of rectangle A. That's intentional. Here's your task. You need to determine the side lengths of each rectangle. Label each rectangle with the length of its short side and the length of its long side. So you're going to write it right on the cutout that you're doing. Ava and Gabriel each group the rectangles in different ways. Use your cutouts to make sense of their reasoning. In other words, put the cutouts in these 2 stacks. Look at them and see if you can figure out how they reasoned to put them together. I will give you a hint. If you line them up from smallest to biggest within each of their stacks and put all the bases or the bottoms together in the same direction, it should help you see what they did. So Ava put these rectangles together. I need you to write down what you think her reasoning was. Gabriel's was different. He did start with rectangle A, but then he used these rectangles. We want you to figure out what his reasoning was. If you've done all that and you can't figure it out, the tables are going to be a good help for you. So what you're going to do is complete each table. There's your task. Write the ratios in fractional form, comparing the length of the short side to the length of the long side. I'm doing a lot of marking the text and I'm not seeing anybody's pencils moving. That's disturbing to me. I will let you know, last period alone, over half of the students got this problem wrong because of something that I just underlined, and I'm not going to tell you what it is. So I will also add in, marking your text isn't helpful if you don't pay attention to what you mark. So once you've done this, you're going to go to the table, and you're going to write these as a ratio. I will give you a hint. Simplify all of your ratios, and you will see something very stark in the difference between these two tables. Once you have done that, you're then going to compare the ratios in each table. What do you notice? There's a lot of different things that you may have noticed. There's a couple of things that I will point out that I hope you guys figure out. So you can see we have a lot to do, right? I'm going to give you guys about 20 minutes to get all of this done. So go ahead and go to page 239. You're going to tear it out of your book, and you're going to start cutting. Keep your stack. Okay, so hopefully you guys were able to get this figured out. I'm going to start with the table, and then we'll come back to it. I apologize, I was still grading mine, so I didn't get to take a look. When you wrote the ratio, how many of you guys wrote it like this? Please raise your hand. Only 5 of you? Seriously, there's only 5 people in this entire classroom who wrote the ratio like that? Okay, now I'm getting more hands up. I'll give you guys a hint. Robin was like my #1 student last quarter. He had 100% plus every quarter. He has his hand raised right now that he wrote it like this. So let's ask this question again. How many of you wrote the ratio like that? Okay. Glad to see so many jump on the bandwagon because I'm going to make a point. Robin, did you mark your text like I told you to?
Yes, but...
Did you pay attention to what you marked?
Yes, I did, but I forgot to do the...
Because what does this say right here?
I forgot to do this.
Cloud looks very excited right now. Because how should that have been written? Now, the reason to write this in fractional form, I will show you on the rest of these. Because if I do 4/10, it's a lot easier in fractional form to simplify. I can divide both those by 2 to give me 2/5. If I have 12/30, I can divide both those by 6 to give me 2/5. If I have 6/15, I can divide both those by 3 to get me 2/5. If I have 8/20, I can divide both those by 4 to get me 2/5. If I have 10/25, it's far easier to divide those by 5 to give me 2/5. Does anybody notice a pattern with what Ava put together? Yes. They're all simplified to 2/5. So using our mathematical definitions, what does that tell me about all of those ratios?
They're all the same. They're all the scale of 2/5.
Okay, so what's the mathematical term for on that scale? What do we call, kind of ratios do we call them? Equivalent ratios, thank you. Because they all simplify to the same number, they are equivalent ratios. Now, when I look at Gabriel's group, we'll see something a little different. 2/5, can I simplify that? No, they started the same, didn't they? But did our groups look the same? Why? Let's look. This one is now 5/8. Can I simplify that? No. 6/9, I can divide by 3 to give me 2/3. 3/6, I can divide those by 3 to give me 1/2. 7/10, can I simplify that one? What about 4/7? No. So did I end up on that in this case with the same number for all of them? So this should tell you something very important about these two tables. So I think Ava's pattern becomes very easy to spot, right? What could we say about Ava's pattern? Anybody? We already said it. I don't know why you won't just repeat it. Adam? Okay. So Ava's ratios are all equivalent to 2 over 5. That's a 5, not a 6. My pen didn't lift up right. 2 over 5. Does anybody notice a pattern with Gabriel's group? Nobody?
No. There's on.
You see a pattern? No? Look at the numbers, guys. Robin? So here's one of your future stars if you're sticking around. Did you hear him? For those of you that didn't hear, we can add something on Ava's. She used multiplicative reasoning. Gabriel added 3 to each short side. He used additive reasoning. Now that Robin pointed it out, does everybody see? If I add 3 on all of these, I get my second number. Seeing it now? So I'll give you guys a second to write this part down. Probably not the best time to have been out. You just missed a whole lot. So get it from one of your table mates. Okay? Which actually kind of answers these two. She used multiplicative. Let me try that again. There we go. So that answers all of our questions on this page. Our next set also kind of go together, but this one gets a little more complex, so I really need everybody's attention, please. Okay? So we're going to stack Ava and Gabriel's groups of rectangles from the getting started with the smallest rectangle on top so that their longer sides are horizontal. That means this way, guys. That's horizontal. And their lower left corners align. So in other words, what I'm saying is you're going to take the stack. I'm going to start with the biggest rectangle. Then I'm going to find the next biggest rectangle in that group. I'm going to put it on top of it so that this bottom left corner aligns. And then the next one, and then the next one, until the smallest one is on top. Is that clear for everybody? Okay. Once you've done that, I want you to look at those rectangles. See what do you notice about the rectangles in each group. Make an observation about Ava's group. What about Gabriel's group? You're then going to take them and you're going to start placing them on this graph. So Ava's first rectangle is a 2 by 5, right? So when I take it and I pick it up, I'm going to set it here. It's a 2 by 5, so it's going to sit just like this. I need you to make a mark at that upper right corner. The next one in her group is a 4 by 10. So you're going to set it on here. It's going to look just like this. It's going to come up here, over here. I'm going to make a mark right there at the corner. You're going to do that for every rectangle in her group. Then you turn the page. You're going to do the exact same thing with Gabriel's group. So he started out with a 2 by 5, the exact same one. So when I put it on there, here's what it's going to look like. I'm going to again put a mark there. The big difference is he added 3, so his next one was actually a 3 by 6. So it's going to look like that. The next one was here. So it's going to look like this. You're going to do that with both sets of rectangles. And then once you have done that, I want you to draw a line through the edges and see what you see. Does everybody understand this part of the process? Okay, so step 1, stack it. I would go from biggest to smallest. It's going to make it easier for you. Making sure that bottom left corner is the same. Then you're going to just move it onto the graph paper and trace where that right corner is. You don't have to trace the whole thing. I just need a dot where that upper right corner is. Okay? We'll give you guys about 10 minutes to knock this part out. Okay, let me get back to the first page. When you stacked up, guys, come on now. When you stacked up Ava's group's rectangles, what did you notice about the stack?
They're getting further away.
Okay, they were getting further away. In other words, there was a bigger difference at the bottom, right? I saw someone else with a hand up. Yes.
They away. So if you put A in between, so if you put it A on the bottom and then you draw the dot and put it the left. So if you put it right and then it'll fit right here this time.
Okay. So the base triangle fit between each one, or best rectangle, base rectangle. Let me say that properly. Did anybody notice anything about Gabriel's group?
They were way closer together.
They were way closer together. Okay. Anything else you guys noticed on Gabriel's group? Robin?
The difference in
Guys, please stop talking unless I've called on you.
is that it gets one block higher and one block wider.
Good.
It's 2 blocks higher and 5 blocks higher.
So this one is going up by 1 block by 1 block. 1 block higher and 1 block wider. And then that's kind of where that base rectangle, that 2 by 5 fits between each one. Okay? Good. That's actually some really good observations. Now, as you plotted these out, what you should have seen is it was 2, 5, 4, 10, 6, 15, 8, 20, and I think there was a 10 in there, right? 10, 25? Okay? If you have a straight edge, you should be able to lay that straight edge down, and you'll see that those points all come together and make a perfect line that goes through origin 0, 0. So that means we have a linear relationship between them, and because it is linear and because it goes through 0, 0, that means they are proportional. In other words, it's a ratio. When you look at Gabriel's, you actually should have also seen that you could do a straight line through each of those points. However, the difference is his straight line doesn't go through origin. It actually intersects the x-axis at 3. So, in both cases, it is a linear relationship. The big difference is because Ava's goes through origin, hers is proportional. So when we look at this, the straight line goes through origin. And we haven't really talked about this but here is the term we need. It was proportional. The straight line through his? Yes. Oh, thank you. The straight line. The straight line. Oh, I'm sorry. Did you have something you needed to add? Because I thought I was talking now. Did I miss something? Green shirt. I am sorry, I don't know your name. What's your name? Izzy. Izzy? Did I miss something that we needed to add? Okay. So the straight line went through 3, 0, not origin. So pull out your highlighters real quick or your marking pens. We have one definition to mark. When a set of points, come down. What the heck? There we go. When a set of points graphed on a coordinate plane forms a straight line, that is a linear relationship. Okay? You can represent equivalent ratios on a coordinate plane by plotting the ratio y over x as the ordered pair xy. So you just reverse it to put it on there. When you connect the points that represent the equivalent ratios, you form a straight line that passes through the origin, such as Ava's. Non-equivalent ratios are those represented by points that do not create a straight line through origin, like Gabriel's group. So that is your biggest difference. Equivalent ratios will always form a straight line that will always go through origin. Non-equivalent ratios can form a straight line, but they are not going to go through origin. Any questions on anything that we have covered today? Okay, your homework, really simple, one Matthew workspace. You're doing the one using graphs to determine equivalent ratios. That should be number 8 out of 20 in Module 2, or if you're doing the overall tracking, this is now 38 out of 123. Okay.